This video will go over solution prep calculations. By the end of the video, you should be able to complete the pre-lab calculations for week 1 of pH and conductivity. A solution is a mixture of a solute or solutes and a solvent. Because we can adjust the amount of the solute or the solvent in the mixture, we have a ratio between the two. This ratio is known as concentration. Concentration is defined as the relative amount of a component of a solution. So it's a number that tells us how much solute is in the solution. The term concentration is an umbrella term, and there are many units that can fall under the heading. So some examples are percent. If you're talking about very small amounts of solute, you can talk about parts per million. And if you're talking about even smaller amounts of the solute, you can talk about parts per billion, or ppb. The unit that we most frequently encounter in chemistry is molarity. Molarity is defined as the moles of the solute divided by the liters of solution. So the amount of the solute is quantified in terms of moles, and then the amount of the solution, which includes the solute, is going to be in terms of a volume, and the unit being liters. In a lab, you usually measure a volume in terms of milliliters. So it's necessary to convert between milliliters to liters. So it's important to know the conversion factor. And if you have 1,000 milliliters, you have 1 liter. So you can use that to go between milliliters and liters. We can abbreviate molarity by writing M equals N over V, where N stands for moles. So what you'll typically see is a number followed by the letter M, and what that stands for is moles per liter. So a way to understand what this means is, for this solution, if you have 1 liter of the solution, it's going to have 2 moles of the solute dissolved in it. That's the ratio. Now, in terms of calculations, the first type of calculation you're going to have to do is to prepare a solution that has a particular concentration and a particular volume, and you're going to be starting with the solute as a solid. So what we need to know is the mass of the solid needed to prepare 100 milliliters, that's the volume, of a solution with a concentration of 0.5 m, 0.5 moles per liter. So in this case, calcium chloride, that is our solute. It's a solid, so we basically need to know how much of this solid do we put in the solution so that we end up with a volume of 100 milliliters, and then we have a concentration of 0.5 moles of calcium chloride per liter solution. So this is our M. So now what we're given is V and M. Well, we know that there's an equation that relates V and M to moles, to N. What we can do with this equation is solve it for N. Once we do that, then we'll have ourselves moles, and then we can convert moles to a mass in grams by using the molar mass of calcium chloride. So that's going to involve looking at the periodic table. So if we want to rearrange this equation for N, we have to do one step of pretty simple algebra. And so if we get N by itself, we have to multiply by volume on both sides. So we end up with M times V. We're given an M, so we can plug that in. .500 moles per liter. That's what M stands for, once again. And now we're given a volume. The volume is 100 milliliters. We know that molarity is defined as moles per liter. So we're going to need to convert from 100 milliliters to liters. So we'll do that right down here. So 100 milliliters times our conversion factor And we know that there are 1,000 milliliters, 1 liter on the top. And so the reason I set this up like this is because if we have milliliters on the bottom of this fraction and the top over here, then they'll cancel out and we'll get liters. So then mathematically, if you do 100 over 1,000, that equals 0.1. So 0.1, in terms of sig figs, we have 0, 0, 0. Okay, so n in this case, if we take 0.5 times 0.1, we get 0.05. Now remember, we're calculating n here, so the unit is what? The unit is moles. Okay, now remember, the question originally asked for what is the mass of solid CaCl2. We have ourselves moles. So the way you convert between moles and grams is by using the molar mass from the periodic table. So we have our formula, CaCl2. We have 1 calcium. And from the periodic table, we have 40.08 as the molar mass. We're going to add that to 2 chlorines. And from the periodic table, it's 35.45 in grams. I forgot to put grams there. Okay, now we just multiply in the parentheses and then add everything up. So 40.08 times 1 is 40.08. And then to that, we're going to add 2 times 35.45. And so we get 110.98 grams over 1 mole. So this is our conversion factor. So going back, we have this number right here. We need to know what the mass of 0.05 moles is. We know that 1 mole is 110.98 grams. We have much less than 1 mole. We have 0.05. So we're going to end up with much less than 110.98 grams. So I'm going to rewrite the number that we calculated earlier. Zeros that I had 2 zeros. Moles times. Now, I want the unit moles to cancel. So that means that I'm going to put it on the bottom. So I'm going to put 1 mole on the bottom. And then I'm going to put 110.98 grams on the top. All right, in the calculator, we're going to do 0.05 times 110.98. And then what we get is 5.549 grams. If we look back in terms of significant figures, this one has 1, 2, 3. And then the molar mass has more than that. It has 5. So our answer can only have 1, 2, 3. We have a 9 there. So we're going to round the 4 up to 5. So that equals 5.55 grams. That's our answer. Okay. The next type of calculation that you're going to need to do involves an equation that's known as the dilution equation. So, excuse me, let me just zoom in. So a dilution, if you think about what dilution is, if you have say you have a drink and it's a powdered mix and you taste it and it tastes too strong. Well, you dilute it by adding water to it. And that's exactly what dilution means. So if I have my drink mix, okay, there's my drink. And then I have my solute, my drink mix dissolved in it. So I have that much. When I dilute it, all I'm going to be doing to it is adding more water. So what I end up with is more volume in total. But if you think about it, all we did was we added water. We didn't change anything else about it. So that means that we have the same exact amount of solute particles after we dilute it. And so from this fact, the fact that the moles of the solute before equals the moles of the solute after, we can take and substitute in for N, if you remember from earlier, N equals M times V. So going back, I can write M times V, and this is B, we'll put B for before, and then M times V, we'll put A for after. So usually the way you see this equation, which is known as the dilution equation written, is M1 V1 equals M2 V2. So the most common way you're going to need to use this equation is by being given a stock solution that has a known concentration, and by being told, well, you need to make it at a particular concentration and a particular volume. And then from that, you can use this equation to calculate how much of the stock solution that you'll need to get that solution prepared. So that leads us to our last question here. So let's say we have a stock solution of copper sulfate, CuSO4. It has a concentration of 0.80 moles per liter. What volume would you need to prepare 500 milliliters of a 0.04 moles per liter solution? So if we break this up, we have two solutions here. We have our stock solution. The stock solution has a concentration of 0.8. And then we have we'll call the new solution. The new solution has a concentration of 0.04. And the other piece of information we're told about it is that the volume is 500 milliliters. What we need to find out is how much of this solution we need to dilute to get to 500 milliliters. So we need to know how many milliliters of this. Okay, so let's do some labeling. We have M1, V1, M2, and V2. We're going to go back up here and do some labeling. So we have the stock solution that has a concentration of 0.8. So in this equation, we can call this M1. And then it says, what volume would you need to prepare 500 milliliters of a 0.04 M solution? So that means that 500 milliliters, that is the new volume. So we'll call that V2. And then 0.04, that is going to be the new molarity. And so essentially in this question, what we're after is V1. We don't know what that is. So the first step is going to be solving this equation for V1. So that's going to involve moving M1 over to the other side by division. And so what we end up with is V1 equals M2 V2 over M1. Now we can plug in the numbers that were given. So M2 is the new concentration, and that was 0.04 moles per liter multiplied by the new volume, which is 500 milliliters. So 500 milliliters, remember, needs to be converted to liters. 500 milliliters equals 0.5 liters. So 0.5 liters. And then finally, we're going to divide by the original molarity, which in this question is 0.80. Okay, so what we are doing mathematically is we're going to do 0.04 times 0.5 divided by 0.8. So what we get is 0.025 liters. And in a lab, if you're going to be measuring this actual amount out, it's going to be in milliliters. So we need to convert this volume back to milliliters. And the way you do that is you multiply by 1,000. So if you take 0.025 and multiply it by 1,000, you're essentially just moving the decimal over to this, 25 milliliters. So that represents how much of that original solution you would measure out and then dilute to 500 milliliters in order to get there. I hope you found this video helpful, and good luck on the pre-lab.